Hello, all my lovely math people out there. This lesson is about using geometric formulas. I would argue all math is useful, but I think this lesson is particularly useful. Formulas are really, really helpful to help you find information about real life stuff. So if you're one of those people that kind of hates on math, which boo on you, you might, hopefully this lesson you can find sort of useful in your actual daily life, okay? So what is a formula? A formula is an expression that includes numbers and variables, and you can use that to calculate a desired result. Usually with a geometric formula, we're calculating we're calculating information about physical features of the shape, like the size of the shape. It could be certain lengths. It could be like the space outside the shape, the space inside the shape. Okay, so we're talking about something really physical in real life, which is dope. Okay, so for example, if we look at example 1, Zoe receives a package in the shape of a rectangular prism with the dimensions shown below. What is the surface area of the package? So we've got this package here. Surface area is all the space outside of it. And even if you don't know that, if I tell you, hey, the surface area of a rectangular prism can be calculated by this formula. So here's an example of a formula. Oh man, where's my yellow highlighter I want to use to show you? Oh, here. I'm talking about a geometric formula. Here's an example. Okay, we can use to calculate that information about this shape, okay? Now, formulas, it might look complicated. Like, what is all this going on? 2L plus 2LW plus 2HW. Okay, formulas represent certain dimensions of the shape. Okay, dimensions are information about the shape, okay? And I made this lovely rainbow, lots of colors, because every formula is different and includes different dimensions. Okay, so in this one, it looks like we're talking about, it says where h is the height. So we're talking about a height, L is a length. So maybe height is like this, right? Like that's 7 inches. We're talking about L being the length. So L, length, let's maybe make it this 4 is 4. And then W is the width. So how wide the object is 5 in this case, okay? So how we can use this formula to compute the surface area is we find the dimensions in the formula, which we just did, right? I just determined that the height was 7, the length was 4, and the width was 5. Honestly, it doesn't matter, like for this one, which is which. Like if you wanted to make the length 5 and the width 4, you could do that. In some cases, it will matter. But we're going to use what it told us to do, okay? So, this will work for now, okay? Then you're going to substitute the dimensions into the formula and simplify. So basically, I'm going to do 2, and then I'm going to substitute a length and a height, right? So length is 4 times 7, okay? Plus 2, the formula says, times a length, times whatever the length and the width is. So my length is 4, my width is 5, plus 2 times height and width, or sorry, 2, oh, I'm running out of space. Height is what, 7? Width is 5. Okay, then I'm just going to do the math on that. So I'm substituting into the formula, and then I'm simplifying. So I'm just going to actually calculate 2 times 4 times 7, which is, sorry, let me grab a calculator really quickly. Okay, 2 times 4 times 7 is 56. Plus 2 times 4 times 5, that's going to be 20 times 2 is 40. Plus 2 times 7 times 5 is 70. Okay, I'm going to add those 3 numbers up. 56 plus 40 plus 70, just doing that on my calculator quick, and you get 166. My units are going to be squared because I'm talking about area. Okay, cool. Let's do another one. All right. The given period has a pyramid has a square base with a side length of 10 inches and a slant height of 5 inches. What is the total surface area in square inches of the pyramid? Okay, and then notice here it says total surface area is this formula. So I have a formula here where I'm going to figure out what the dimensions are. Okay, it says where P is the perimeter of the base, L is the slant height, and B is the area of the base. Okay, so this one, there's some extra work that needs to happen. If you can, I'm gonna try and draw myself a little picture. Okay, so it's a given pyramid has a square base. So a base we're talking about, it's a square, and what did it have? It has a length of 10 inches. Okay. Then, because it's a square, let me do this. All of them are going to be 10. Okay? Dope. Okay. Then, a slant height of 5 inches. So I'm drawing a pyramid. I'm going to make it go like this. Oh, man. Here she is. Okay. L is the slant height. Even if you were like, I don't know what this is in the picture, L is the slant height. You don't need to do any more math for the slant height. You can just leave it 5. Whereas for P and B, I'm going to have to do perimeter and area. So I'm going to have to use this to do some stuff with the base. I'll just show you that slant height is that. It's like the height, the slanted height from the base to the top of the pyramid. But we know L is 5 because we were told that slant height is 5. Okay. Now we're going to have to do some extra work to calculate P. P is the perimeter of the base. So, to find P, I'm going to do 10 plus 10 plus 10 plus 10. So 4 times 10. So that's going to be 40. Okay. It says B is the area of the base. So sorry, let me color code. P is the perimeter of the base. So that's why I did that there. B is the area of the base. So it's a square, so I'm going to do 10 times 10. And get 100. Okay, dope. Now I figured out what all the dimensions were of the formula. Okay, I figured out what P was, what B was, and then I was just told what L was. Okay, and so now I'm going to start plugging into the formula. So I know surface area is equal to 1/2. I got to insert P, which is 40. And then L, which is 5, plus B, which is 100. All right, then I just gotta do that math, okay? 40 times 1/2, 40 times 5, 20 times 5 is gonna equal 100. Plus another 100. My surface area is gonna equal 200 inches. It said square inches, so inches squared. Okay? Cool. Hope that made sense and that you wrote everything down and like understood it and listened and stuff. Okay. Now let's jump to one again where perhaps the it's not so obvious what you need to do, okay? So, let's look at 6. A carpenter plans to paint the top of the trapezoid shown below. How much area will he paint? Area of a trapezoid is this, where B1 and B2 represent the lengths of the parallel bases, and H represents the height of the trapezoid. Okay, so let's use our who problem solving. So what do we want? We want the area, right? What do we have? Well, we know that the area is going to be equal to 1/2 B1 plus B2 times H. So how am I going to organize my thinking? Well, I'll give you a hint. If I were you, I would start with trying to figure out what B1 and B2 were, right? So what's B1 going to be? What's B2 going to be? And then what's my height going to be? And then using that to calculate my area. But I'm going to let you take it from here. Hope that made sense. Okay, formulas are really nice when you get used to them, okay? Here's Piplup saying, hey, and that you got this. Okay. Thanks for listening. Hope that made sense.